Hey guys, today we are going to solve radical equations. So some of the things we need to keep in mind is when we have radicals, there are some solutions that don't work, right? Because we can't take the square root of a negative number, so on and so forth. So when solving, we have to make sure that we are checking to make sure we don't have extraneous solutions. In other words, they really don't work. So a radical equation is an equation that has a variable in the radicand and a variable with a rational exponent. So for example, we have the square root of 2x plus 3 equals 4, or 4x minus 1 to the 1/3. Now remember, 1/3 is the cube root, right? So there are some things to think about as we're solving. So here are some steps that we can follow each time. Isolate the radical on one side of the equation, raise each side to the power of the index, so that's the root, simplify, and then don't forget to check solutions. So here's an example for you that is typed out. So the first thing we're going to do is get the radical by itself. The radical is that radical x plus 3. Now, we cannot combine these two. So I'm going to give you an example. Sometimes it's written like this: -7 plus 2 square root x plus 3. Okay. Do not combine these two. You cannot combine this because this -7, it's subtracting 7 from the radical, where the 2 is multiplying. Those are two different operations. So we cannot combine those. So we'll do them each separately. Okay. But let's go back to the original setup. So this would tell us to add 7 to both sides first, move that over. Then to get rid of the 2 there, we divide by 2. Okay, and now we have our radical by itself. How do you get rid of a square root? Well, we square both sides. So we're going to square both sides, leaving us with x plus 3 on the left. 3 squared is 9, so be careful of that. So then we solve. So to get rid of the 3, we subtract 3 from both sides. So we get x equals 6. Now don't forget, we need to double check this answer. So what we're going to do is plug in 6 for every x that we see in the original problem. So I'm going to put a 6 right there. Now what we're going to do is solve and make sure they equal each other. So 6 plus 3 is 9. The square root of 9 is 3. 2 times 3 is 6. 6 minus 7 is -1. This works. So yes, x minus 6, or x equals 6, is our solution. All right, so let's do a couple together. So we're going to get our radical by itself. So I'm going to subtract 4 from both sides, giving us the square root of 3x plus 10 equals 5. Our square root is by itself now, so let's get rid of it by squaring both sides, giving us 3x plus 10 equals 25. Now we have a two-step equation to solve. Subtract 10 from both sides. 3x equals 15. Divide by 3, so we get x equals 5. Now let's double check. So we're going to rewrite the problem, but for every x I see, I'm going to plug in that solution. And we're going to see if it equals 9. So 4 plus the square root of 15 plus 10. So we have 4 plus the square root of 25. We have 4 plus 5. And does that equal 9? Yes, it does. So x equals 5 is our answer. Example 2, same setup, but of course, instead of a square root here, we have a cube root. So I'm going to add 1 to get that radical by itself. So we get the cube root. Don't forget to put that 3 there for that index, because then we think of it as a square root instead. So be careful. equals 3. Now, how do you get rid of the cube root? We cube it. Get 2x minus 5. If you need a calculator, do so. 3 cubed is 27. And we're going to add 5. Trying to show my work. So we get 32. Divide by 2, we get x equals 16. All right, let's double check our work here. So for every x that I put in, I'm actually going to do a 16 there. So 2 times 16 minus 5 equals 2. -1 plus the cube root. Let's see, 2 times 16 is 32. 32 minus 5 is 27. If you need a calculator, do it. The cube root of 27 is 3. And what do you know? -1 plus 3 is 2. So 16 is our answer. All right. Now here we have 2 x's. So this is going to be one of our trick ones. So always come back to that if you find that you have an x on both sides, because there's going to be an extra step here. So we're going to get the radical by itself by adding 7 to both sides. The radical is by itself. Sorry, I put 9, but it should be 7. So that means we're going to get rid of it. We're going to square it. Now be careful here. Yes, on the left side, we end up with x plus 9. But on the right side, you have to keep in mind that x plus 7 squared is x plus 7 multiplied by itself. And we usually do our box or we FOIL. So we get x squared, 7x, 7x, 49. So on the right side here, we get x squared plus 14x plus 49. Because I see an x squared there, that should tell me, ooh, I might be factoring. So let's get everything on the side with the positive x squared. So we're going to subtract x from both sides, and we're going to subtract 9 from both sides, giving us 0 equals x squared plus 13x plus 40. Now, I'm going to factor quickly. If you can't remember how to factor, go back to unit 1 where I had the factoring video, or just remember to do your box backwards, okay, or grouping. So get 0 equals x plus 5 times x plus 8. So the two solutions right now that we have are x equals -5 and x equals -8. I have to check both answers. So let's check the -5 first. We're going to put in -5 for both the x's. So square root of -5 plus 9 minus 7 equals, well, this is x, so x is -5. Okay, -5 plus 9 is square root of 4 there. Minus 7 equals -5. Square root of 4 is 2. 2 minus 7. Does that equal -5? Yes, it does. So -5 works. Now let's check our -8. Square root. So it's -8 plus 9 minus 7 equals. Now it's supposed to be x. So our x in this case is -8. So we get the square root of 1 minus 7 equals -8. 1 minus 7. Does that equal -8? No, it doesn't. So that means -8 is an extraneous solution and we can cross them out. And the only solution that works is -5. Again, remember, if there's an x on both sides of the equal sign, come back to this example to remember to do that multiplication. All right, now let's practice some with rational exponents. Now, here is a rule or setup that you can use, but I tend to do them separately because I like to do some math in my head if I can, just to make sure I understand what's going on. So remember that radicals can be written as rational exponents. So the root is in the denominator and the exponent is in the numerator there, right? So I can say n over m. Recall that when a rational number is multiplied by its reciprocal, the product is 1. So to solve radical equations or rational exponents, solving for them, what you're going to do is raise each of the side of the equation to the reciprocal. Now, that is a quick way to do it, but really to understand it, I will show you how to separate so you know what's going on. Because the other thing is, anytime we take an even root of both sides, it's a plus or minus. So we have to remember that. So let's look at this. We're going to get the rational exponent or the radical part all by itself. So I'm going to subtract 5 first. We get 2 times x plus 1 to the 2/3 equals 8. Now we're going to divide by 2. So we get x plus 1 to the 2/3 equals 4. Now I'm going to do these separately. So in other words, the 2, to get rid of a square, we take the square root. To get rid of a 1/3, we do to the power 3. So I'm going to do this separately. I like 4 as a perfect square to break it down smaller so it's easier to cube it. So I'm actually going to take the square root of both sides. That leaves us on the left side with x plus 1 to the 1/3. Okay, because I got rid of the square. Now, when I took the square root of 4, I actually get plus or minus 2 because it's an even root. So if I was taking the 4th root or the 6th root, it would be a plus or minus. That is because in this case, 2 times 2 is 4, and so is -2 times -2 is 4. All right, how do I get rid of a 1/3? Well, that's like a cubic. So to get rid of that, we do it to the 3rd power. See how those would cancel? Whatever I do to one side, I do the other. On my left side here, I get x plus 1. And on my right side, well, 2 cubed is 8, and -2 cubed is -8. Now, this is where the tricky part is, because, of course, to get x by itself, we're going to subtract 1. But there's actually 2 answers here. So I'm going to separate these. So get x plus 1 equals 8, and x plus 1 equals -8. So when I solve, I get x equals 7 and x equals -9. I have to check both answers. 2 times 7 plus 1 to the 2/3 plus 5 equals 13. Okay, so that's 2 times 8 to the 2/3 plus 5 equals 13. I'm going to show you guys how to do this on your calculator, just so it's easier to check our answers, okay? Okay, so 2 times 8 to the 2/3 plus 5 and equals 13. So yes, that works. So 7 works. Let's check if -9 works, right? Oops, -9 plus 1. I forgot to put in because I'm doing it to the original problem, right? So -9 plus 1 to the 2/3 plus 5. Does that equal 13? So actually, if we wanted to, we could plug it in right here. 2 parentheses, -9 plus 1 to the 2/3 plus 5. Now, does that equal 13? Yes, it does. So in this case, we have 2 solutions. Okay, so on example 5 here, remember that when we're taking an even root, it's plus minus. Okay, here in this case, okay, I'm going to add 6 to both sides. So 4 the 5th root of x plus 12 cubed equals, I'm going to add 6, so that's 32. I'm going to divide by 4. Cubed equals 8. Now I'm going to get rid of the 5th root. How do I get rid of the 5th root? Go to the 5th. Now, actually, if we look at this, 8 to the 5th is a lot. So instead, this is why I like doing it separately. Instead, I'm actually going to make this smaller. And this is an okay move to do, guys. I'm actually going to make this smaller by getting rid of the cube first. How do you get rid of a cube? You take the cube root of it. Now, because I am taking the cube root of it, it's an odd number there. It's only the positive or negative according to the value. So this is a positive 8. So what times itself 3 times is positive 8? It would be a positive 2. Can't be -2 because -2 times -2 times -2 is -8. So when taking an odd root, we actually do the positive or negative of that. So it's positive. How do you get rid of the 5th root there? We go to the 5th. So we get x plus 12 equals 2 to the 5th is 32. Subtract 12 from both sides. And we get x equals 20. All right, let's see if that works. 5th root x, not x, or x is 20. Minus 6 equals 26. Now, by the way, just remember what we did up here, right? That 5th root is in the denominator. So when I check my answer, I'm actually going to do 4 times 20 plus 12 to the 3/5. That way I can use my calculator to help me. Okay, now remember that root became that denominator, just like our rule up here. So let's check that now. 4 times 20 plus 12 to the 3/5 minus 6, and that equals 26. So we are good to go. X equals 20 is our answer. All right, let's see how you're going to do. Remember to check your answers.